Hi everyone, my name is Grace Farrow and I'm an application engineer here at Prolim, and today we're going to be looking at helpful tools for solid edge design. This webinar is going to go over some tools that a lot of users aren't really aware of that could help with the design process. So we'll get right into it. The first one we're going to look at is engineering reference. Then we're going to go to our geometry inspector command, optimize command, recognize command, and then how to find help. So the first thing we're going to look over is our engineering reference tool. This is a calculation and formula driven design tool that is completely integrated with Solid Edge. It is designed to preserve the engineer's design intent. We can create shafts, gears, and springs. This allows Solid Edge users to employ engineering calculations to automatically create mechanically correct parts and reuse knowledge-based engineering principles. So let's take a look at an example of that. So here we can see that I am in an ordered part file. We must be in ordered for the engineering reference tool. It will not show up in the synchronous environment. So there are a couple ways to get to it. We either have the engineering reference tab on the left or right hand side, depending on where you want it. And then we also have the engineering reference drop down here under the tools tab. So you can see that we do have the ability to create several different types of part files from this engineering reference template here. But for our example today, I am going to create a shaft. And you're going to see that these are our parameters and our options that pop up once I select that. So not only can you change the parameters in this dialog box, we can also update the material and change the material values. And then we can go in and change these around. So maybe I want a diameter of 1, a length of 2, maybe apply a radial force here. And once I have those parameters set, I'm just going to select calculate, and that's going to take us to our calculated results on the next tab. So once we have our calculated results, we can now check our figures to see if our part is strong enough for its intended use. We have graphing options, XYZ plane, XZ plane. And then from here, we're just going to create our create button down at the bottom. And it will automatically create the shaft for you. So we can see here, I'm just going to name this as test 1. And now I can open that part up, so let me do that real quick. So this is our final product using our engineering reference shaft design. You can see here that we do have a lot of features that are suppressed, but if we came in and changed the options, those would all be updated. So let's say that I want to place this in an assembly file. And once we place this shaft design in an assembly file, we can edit it with the engineering reference tools. So let me save this real quick. So now if I right click on my part, I can say edit in Solid Edge Shaft Designer. We can go back in and change those parameters. So like I mentioned before, if we look at some of the other parts you can design in the engineering reference, they all work in a similar manner. You simply substitute the default values for your own, and don't forget to add a load, calculate to check your results, and then create your parts. So this is a really useful tool that will help save time when designing and creating those components. So the next tool we're going to take a look at is our geometry inspector command. So this command detects flaws in model geometry, and it provides information to help you understand and resolve the errors. You can identify flaws in imported models, which may cause problems in Solid Edge, or you could simply use it to simplify Solid Edge models for finite element analysis. So we're going to take a look at an example of that now. So like we talked about on the PowerPoint, we do have the ability to use this tool on imported geometry or for Solid Edge models. So in this case, we are going to look at an imported part file. This is a right angle speed reducer, and we are going to go to our Inspect tab, which is where our Geometry Inspector is. We are going to inspect this geometry. We do have a significant amount of options here. We can either decide that we want to look at all active models. We can select active models. We can look at all mesh models. We can look for faults in small entities, and that includes faces, edges, spikes, right? And once we have our settings set up the way that we want, we say go. And the results are going to be in individual nodes here. So we can see here that I have 344 small entities, but I don't see any faults down here in my result description. So we can see if I come down to the bottom and say heal body faults, what's going to pop up is down here in the results description a kind of more detailed process of that. It says, so no faults found with the specified model in this document, which is awesome. I don't need to do that. We do have a couple more options down here at the bottom that says mesh body healing options. So that's like deleting faces, filling holes, right? So this is kind of just a really unique tool that helps you, especially with imported geometry, helps you maybe fix some of those faults or small entities that cause issues. So the next command we're going to look at is the optimize command, and this is used to analyze imported data and improve the quality and precision of model geometry. The improvements can be made by simplifying the B-spline definition, healing edges, and also identifying blend-like faces. So we'll take a look at an example of that. So for this example, we are back on that angle speed reducer, and we are going to use the optimize command, which is right under that geometry inspector command. But what I want to come down in the Pathfinder and notice here is if I actually hover over that body feature 1, it actually gives me a prompt to change or improve the quality of this body using the optimize command. So in doing so, we're just going to select our optimize command. That's going to select our design body. We do have some options in here to actually say we want to clean that body, full body optimize, simple body only, and generate a report. Once we have our options selected and we hit finish, this should only take just a second, but what it's going to do is it's actually going to generate an optimization report. And this, we can look at this and go through, before and after for the numbers, as well as maybe like the face count versus the edge count here. You can see before we did have a total of 1,037, and now we have a total of 1,021. So really just making our geometry better in our model overall. So once I say okay, that's all it takes. It's super easy. So now those improvements should be moved through to when you want to design something off this, and this will help with the quality as well as the precision of the model geometry. So the next commands we're going to look at are the recognize commands, and we have the ability to recognize hole patterns, and chamfers. So these tools can be used in the synchronous environment. They are a set of helpful tools that quickly recognize features in an imported file. So we are going to take a look at an example of using this tool. So for this example, you can see that we are still using that angle speed reducer, but now we are actually in the synchronous environment, so we can get those recognize commands. So that is under our inspect tab, and it's right below optimize, and you can see here that we have the ability to recognize holes, recognize patterns, recognize chamfers. So maybe if I wanted just on this part as an example to say recognize chamfers, it's going to pop up this dialog box. I can decide if I actually want to recognize these chamfers or if I want to toggle them off and not have them actually recognized, so they will not show up in our Pathfinder. But once I do, I can say OK. Now you can see on our Pathfinder that I have 12 new chamfers, and we can actually come in here and edit those as we want to using the, handle there. So this is another model that we're going to use for our recognize command. So we can see here that we have 3 holes, and I want to recognize these holes, right? This is a part copy. So recognize holes, you can see here that I have a 3 count. I can come in here, change the feature name if I want to, maybe change some save settings. Alright. I also have display like the hole type dialog here, okay? So once I say that, I'm going to say OK. And then that will appear on the Pathfinder. All 3 of my holes that I can go in and edit. So the last subject we're going to talk about today is how to find help. So let's say that you are not the most practiced in designing in sheet metal, and you need to better understand some of the commands and maybe some of the options with those commands. If we actually hit the F1 key while hovering over that command that you need help on, it will take you to a Siemens Help and Training online link. Here you can use the training material, or you can come down and take a more detailed look at some of the command options. And there is a search bar, so while you're in here, you can actually search for other commands and other training material. So we'll take a look at that. So I am back on that angle speed reducer, and let's say that I have, maybe some questions on how to use maybe some simulation tools or some PMI tools. And I really want to know more about this section by plane tool here. So I'm going to hit F1 on my keyboard. And this popped up on my other screen, but it will take me to a link where you can see this is our section by plane command, and it has a more detailed description of how to utilize this tool. And we can actually look on the right hand side here, and this will give us kind of more detailed options of maybe how do I create a 3D select view in the synchronous environment versus the ordered, how do I apply or remove a section view. We also have looking things up in more detail and related topics down here. But let's say that while I'm still working inside the synchronous environment, maybe I'm new to it and I don't know much about the design intent. I don't have to go back into Solid Edge to look that up. I can actually just come over here into the search bar, enter in design intent, hit enter, and it will bring up training guides as well as help guides, and we also see this new to Solid Edge start here. So this is a really useful tool. It will help a lot with finding new information, finding better information for you for utilizing different, more complicated Solid Edge tools. Thank you for joining our webinar today. If you have any other questions or comments, you can always email me, grace.farrell@prolim.com. And again, my name is Grace Farrow, Solid Edge Application Engineer for Prolim, and I hope everyone has a wonderful day. Thank you.